Hello everyone, my name is Rene Maas. I'm a lecturer of DK, University of Applied Sciences, and I'm mostly teaching intelligent transport systems and automotive informatics. But on this course, we are going to cover practical activities of mobility and using the GIS tools for that. So let's move on. This course is developed by help of the Inteltrans project, and the course overview is that this is a 3 course. We are going to meet by video 8 weeks, and you have to make a project. So you have to form a teams, and you have different tasks as an individual tasks and as a group tasks. So like I said, this is a mobility and GIS course. So we are going to use one specific GIS program, this QGIS, and after the data we are going to manipulate, we are going to propose a non-motorized street network layout. So the course main topics are this is the data-driven approach to make traffic-related decisions. Contradictory to traditional approach, what is more intuition and legacy-based. It doesn't mean that other approaches are bad. Like I said, intuition and data-driven has to be in hand, as that means this should be support each other to make a decision. Why is this course important to new transport area workers? Because data-driven approach is like a change in mindset. We want to know what data we will have to use and how we use it to make understanding from it and to make decisions based on the data. We also try to spatial data manipulation, what is very important for the traffic workers, and try to interpreting results. We are going to learn a QGIS, and we make it like hand in hand. As we learn in QGIS, we are also implementing in real project, and implementing a project is very important. You know, when you are going to the real work life, you have to contribute many projects, and this experience is very important for you in future. So course construction, it is a project-based course, like I said, and there is 2 options. You can form a teams with 3 members, or you could be made as one-man team. Whatever you choose, you have to choose one of them. We have an individual work as a Moodle. Moodle is our learning management system. There are some self-tests you have to take, and also we have group work tasks and tasks, and also the project as overall. I will explain it a little bit later. We have huge focus on collaboration and individual contribution. Our goal on this course are to give opportunity to work with spatial data in QGIS and make argued decision where to make non-motorized street network. So, like I said, we have to use spatial data. We want to make an argued decision where we should make those non-motorized street. That's what is our output, the non-motorized street network. For that, we have to take a spatial data, we have to manipulate it, we have to interpret. So you have to plan a little bit. Yeah. So first, inspect goals and outcomes. When the week starts, please just watch once on the Moodle to see what is the instructions of this week, and of course make all tests and assignments on date. Also, you should reflect to final documentation what you have done and how you did it. How I assess during the course. During the course, assessing includes following. We have self-tests, and they will be found in Moodle. I will show you this in later. We have also a project. This is a group work. As I said before, you could do it as a one man or as the group of maximum of 3 members. So let's go to the course in Moodle, and you see this is the front page. Here we have little goals, what you are able to do after completing the course. Here you see a course information. This is my name and contact. Here you see how I will create a course and what I will assess during the course. So on every week, please start reading first the week learning instructions. Do this step by step, and I hope you are very fine. When you have questions, please contact with me. You see on every week there is a lecture video. Those are in YouTube. Also there is a lecture slides that supports the video lecture, and when you see IND, that means individual work or assignment. So you have to go over here and submit your task over here. On the week 3, you see there is a group selection. Over here you have to choose one project, and all those projects are a little bit different, and they are different from the student maximum number of schools. When I click over here, you see new drive appeared, drive folder, and you have to download from the drive a QGIS data for drive, and the maximum number of students per school is over here. You have to use them in half gravity model. You don't know exactly at the moment what is that. We will explain it later. You also have to submit one group work over here, and then there is a final project link submit, and you have to submit the final project link. So I want Google Drive link in here. So this is Moodle. Let's go back to the presentation. So course structure. We want to know where is the most beneficial to make a non-motor traffic streets. For that, we have to gather the dataset. Through the course, we see how to get this data. We want to manipulate data in QGIS and then form a decision where are the most beneficial to make a non-motorized traffic streets. Also, we add little theory like a 4-step mobility forecasting model. What is data? You have, of course, heard about data, but what is data? Data is something that reflects real-world entities. So imagine the world where you don't know nothing about what's going on. You need data, like how much is the wind speed, or how many raindrops there is per hour, how many inhabitants commute morning to their work, where they work. So where we hold data? We hold data in database, and also GIS tools that we are going to use also hold them in database, but it's hidden in the application. How we so take into account to understand where people commute. So this is the one question to answer, to think about a little bit and answer by yourself. Data and the question. Let's assume that we have city without public transport system, and we want to make a transport network there. This is an imaginary thing. So where we should start to plan our network in context of using mobility data. What data we could have for that? So we have to first think about where people live and where they are going to work or where they commute. When data is captured, what next? What is the next thing to do with data after acquiring it? What mostly people want from data? Why we collect data? Like I said, when we have data, we could try to make information from that. For this, we have to manipulate data somehow. And through this course, you will see how to manipulate it. Today's word give us many technological ways to understand what is going on in it. So we can acquire information and data faster from longer distances. We could also manipulate data faster, more, and we could also hold data in databases. The data could be also content records. This is the basic example of data on paper, or it could be more advanced, as those records could be in Excel. What are the difference in here is that Excel is the technological thing, and content records on paper, you have to harder to hold the data because it's analog, it's on the paper. You have to make a room for that to hold those records somewhere. Next thing would be how to make a decision. Like I said before, we want to make an algorithm decision where to make a non-motorized traffic network. So how to make a decision? There is rational decision-making process has 6 steps. So let's take them apart. First one is identify problem. So we could ask from ourselves, what is our problem when we think about where to put non-motorized traffic streets? The problem is we don't know where people will want to go, or where they want to go, and why they want to go there. So we have to establish decision criteria. What are decision criteria to think about? So in other words, in our context, in our projects, we want to know how people understand that this money is well spent on that infrastructure we build. So it's very important to think about the criteria. And the criteria could be in our context, as we said, where to make a non-motorized traffic streets network, is that how much people will use it. Weighting decision criteria. We should consider, is that the best criteria, or we have other ones also. So we should take alternatives also into account. Do we have alternative decisions? I think about it a little bit, and yes, we have. People want to feel them protected. So how safe is the non-motorized traffic network street? Non-motorized traffic streets, who will commute in those streets? Let's try to make a profile. So the profile A, so it would be students who will go from home to school. Second one would be people who want to train, make exercises or something. And the third one would be tourists. Yeah, they want to see sightseeing and so on. They want to go on from the airport or from the port to sightseeing. So they are also one profile. So what matters for non-motorized traffic streets users? First of thing, how easy is it to access to network? When it is hard to access, the start of the non-motorized traffic street is too far away from your origin, then you won't use it, because it's easier to take a car. Or second thing is street network quality, and that means when there is much potholes or damaged streets, then users won't use it. They will find alternatives. Parking spaces are very important. When I'm thinking about going to the beach, I want to park my bicycle somewhere. and safety, as I told before, how protected the user will feel, because when it's not protected, as the bicyclist and pedestrians are not so good, not so protected, and when they don't feel like they are protected, they won't use it. So, okay, this was the first part. I covered the Moodle, navigate through the Moodle, what you have to submit, where you find your slides, lecture slides and lecture videos. Also, what we are going to do on this course, like we are going to propose non-motorized traffic street network by manipulate spatial data in QGIS. And we want to make an algorithm decision where this network, street network, should located. Let's start with GIS overlay first. I will explain it, what this GIS is all about, because this is the main tool we are going to use on those projects. So I'm going to start my talk with things like we have two words. We have two words, and we want to know how word is constructed. We want data, how word is constructed, what we have in here, and how it is behaving. So one is nature and self-regulated word, and second one is made by ourselves, and also we have to manage it. We have to manage also the word nature. We have two, context and content. So we have two different focuses. Why we need it is that when we see only, when we want to manage the places, first we want to see the full picture, or sometimes we want to see only full picture. I will show you some examples of what is a full picture and what means the managing the places. So seeing the full is more like patterns or linkages or trends, how word is changing, what behaviors we could see, the patterns, and managing the places are more like zoomed in way of seeing it. We are managing the waterheads or communities or districts. So this is the one example of managing places. You see, this is Rukki Canal, where those ships between Hiiumaa and land Estonia will commute, and there is one problem. When the sea level is very low, the ships will touch the floor, and this is kind of problem. So Estonian Ministry of Transportation made a report of how deep is the channel between those Hiiumaa and mainland. And you see over here that they measured whole channel, and the parts that are too high to get the ships through are marked as red, and all other parts are marked different color. So this is example of matching places. But the second part is seeing the whole picture, and here we see different linkages. Those linkages are Facebook users and who connects with who. We see that there is a huge connection originating or destination in Europe, also in North of America. Also, what we will see more here is that most of the Africa is empty of the connections. So it will indicate us that there is no internet. This is the second picture of the global transportation system, and we see different types of transportation. Like we have shipping routes, we have with the blue we have air networks, and you see we have very huge zip air network between Europe and North America, and we have also global roads. Very many of the global roads are like, and the urban areas that are shown also as the yellow one. So the next thing is about GIS. GIS is Geographic Information System, and I tried to like define it somehow. And first thing is that let's take those all words word by word. And geographic means location-based information at Earth. That means we have almost every time we have some kind of location. We use coordinates to refer to location on the Earth. We have info. This is knowledge about objects or event, and we have kind of system. So the information is organized and operations with them. Also, we manipulate the info and we use the new info as making decisions. So putting together, we have location-based information that has organized information inside it. There are different tools, of course. So Geographic Information System is kind of tool, of course. Here's a little video. You can watch it by yourself. And what are the components of GIS? Hardware is computers and servers to store data. We have this on our table or something. We have softwares and algorithms. This is the second part. And for our project, we use as software algorithms QGIS. Also, we have data in digital forms, data that is stored in the computer or servers and are subject to manipulation. So at the moment we don't have it, but we have to gather it from somewhere. And through this course you will see where you could find it based on your own questions, because we will see why GIS is so important. But who uses GIS? You know, when you haven't heard it before, it's kind of strange who will use it. So international organizations, also private industry, government, and academic institutions like us. GIS and layers. We have to like divide data, and for us is mostly those are like points maybe that could be associated with school coordinates, school places. We have to like divide them as different categorized. We have like layers, what we call for them, and one layer is one type of data. And what we could do in GIS, we could join together different layers and present them on the one map. So at one screen, we are showing different views of this land. On one layer, there could be streets. Another layer could be consist of water area. The third one, buildings, and maybe fourth one, vegetation. And when we put them all together on one look, we have a map that will show us different entities on that land. I will explain it better by one example. And you also start doing this example afterward. Let me open direct data. So at the moment I add like 3 layers. One is protected areas, second one is places, and third one is land use. But we see them all together on one map. That means we could like divide data between different layers. GIS data has always a special or geographic reference, and that means we know where this data came from in the world. Where there are like points on the layer, and we know exactly where they have to locate it on the map because they have coordinates associated with this point. That means we have latitude and longitude. Those are in degrees, but we gonna work with the national coordinate system, and that give us that we could measure the metrics. With latitude and longitude it's harder, and we don't do it. In national coordinate system it's easier. So we are using our national coordinate system, and I will show you. Over here you could change the looking of the map coordinate system. By default it is GIS 84, but we are going to use Estonian coordinate system of 1997 because this is the project coordinate system, and it will give us the opportunity to measure in metrics. And all those layers that I included to the Google Drive folder are in national coordinate system of Estonia. So second very important part about or the feature about GIS is that GIS is info system, of course, where geographic locations are kept with their extra information. And very important part is the extra information, because we call them attributes, and through this course you have to work much with those attributes and inside those attributes. So in this example you see we have field ID and we have call nimi, this is school name in Estonia. We have 1, 2, 3, 4 features, and we call features here as the points. So we have first point, second point, third point, fourth point, and we have for every point we have 2 attribute values. We have field ID and we have school name. When we take the second feature or point, that's the same, we will have field ID 2 and school name Pärnu, Ülejõe school. So GIS data includes always geographic coordinates as x and y, and sometimes that describes what happened on the particular point, but it's not always like that. Let's assume that we have points of cities and we describe them by population. So then what we would have is attribute of population, and for every city there is a value inside the cell of the population. So what really GIS will give us is the opportunity to answer our research question. And it's very important part, because when you start asking questions, your research questions, you start thinking about how to get those answers. As we are going to make a project of about where to make non-motorized traffic road, we first have to question from ourselves that where is the most beneficial to make them. Are the most trips made by bicycle or on foot to school, to work, how long this trip should be, and so on. Then we could start answering those questions in GIS. So what are the GIS functions? So what could GIS in very high level do or makes? First, spatial and non-spatial data assembly. So we could assemble data together, and we see this through the course also. The spatial and non-spatial data storage, also spatial data analysis. This is more like a statistics stuff, and how to manipulate it we will see many times. The spatial data output and visualizing. This part is very important because when you have point layer, so we have many points on the map, and those are too tiny or the contrast with the second layer underneath is bad, then you won't make a difference between maybe the land under the points. So the second GIS function part is the spatial analyzing, and you will see how spatially different like analyzings are made and what are the outputs. When we have is very good example, and we have one layer of like huge map with different parts of land use maybe, and we want to cut out one circle from here with clip algorithm. It will cut out exactly this size of the circle is from this main map. This algorithm we will use also in our projects. There are more than that. So one example of GIS or using a GIS in one project is what problem where we have here is that how much people left in urban areas or working or learning and went to rural areas. Think about it. What data we should consider to see it? I will say the context is before, after the lockdown of Estonia, and this is like week apart. The picture on the right is made a week after the first picture on the left, and you see how much people went to the rural areas, and this project is based on the mobile data, really. Mobile data using. Second example is what we could do with information of where people will commute to park. You will see that with the green there are parks. We have different walking distances. What we want to know is that how far away people will contribute and where they come from really to the parks. We set different distances from park, and we made them with different color, so we could understand when we know how much people would like to walk. We would understand how far away people will come to this park or another park. This is Tallinn non-motorized traffic potential usage. Darker red means higher potential, gray one means lower, and you see the huge potential is near the city center. This is the city center. All other areas also nearby. This is based on how much there are working places, how much there are people living on 1 square kilometer. There is also taking account of where are the schools. Now we are landing to the project part. So that was little overview of what is GIS and what is how to use it, what could be made with that. Also now I will talk about what I want from you as a final documentation of the project. I want to see a demand layer. That is the layer of where students live, how many students live there. We take very standard size, 1 square kilometer, and we see how many students live there. We also have an offer layer, and this is school locations. In every project there is 3 school locations. Also I want the gravity model layer, and that you will learn afterward on this course. This is how each school will pull students from one area, how many students they will pull, and also hot zone. That means where are the most mobility taking place. We connect together school location and area where much of the students would start their trip, and we see we want to place the non-motorized traffic network on that hot zone because it is the most mobility zone. And then we propose a non-motorized traffic street layer. Final documentation should include also theory part that includes what is mobility and GIS. This is the first. So you will made it as a individual work, but you have maximum of 3 members on the group, so you could choose one member work. And mobility forecasting model. This is the 4-step traffic assignment model, and I just want that to see a description of every step. Last one is gravity model sketch of project. There you have to add 3 school positions. You could do it in cookies. Also add for every school a distance between schools, and also how many maximum students could. So the last thing what I want to say about is this week individual work at Moodle. You have to read text and answer the 2 questions. I already show you that a little bit, but you have to define what is mobility and what is GIS. I will accept only answers where used in words. You will use your own words to describe terms. Also include this mobility and GIS definition lecture overview. What happened in the lecture? What this lecture all about? Why it is important to you as a learner or on this course, and what could you do with this information? So again, the context is this course. You could take wider context also. Conclusion and the key takeaways are the GIS is the geographic information system. GIS has data related to some geographic location in space, so that means we have coordinates, and every object or feature has some attributes, and attributes give us an extra information about the point. It doesn't have to be point, it could be also a line. We will see them on the next lectures. And data is saved to database in form of rows and columns. What I want to say about it, you would imagine like Excel table in your head. It's almost the same. And spatial analyze means data manipulation by comparing different layers or add buffers to existing layer. So the analyze big part of our project, so it's good to outline it over here. So that's enough for today. Thank you for your attention, and you make your individual work as soon as you could. See you next week.